Part 3 of using units, we're going to start by looking at some notes on the use of units. Check the list of units in the unit menu to make sure the particular unit you're seeking is defined. For example, for unit of length, you find kilometers, decameters, meters, centimeters, millimeters, micrometers, nanometers, and pentameters. If you need to use, say, hectometers, a hectometer is equal to 100 meters. Such unit is not defined, but you can define it by typing this. And the reason why it's not defined is because it's not commonly used, to tell you the truth. But if you, for some reason, want to do it, go ahead and do it that way. In fluid mechanics, hydraulics, in civil engineering, we're constantly using feet per second, and we call it FPS and gallons per minute, particularly in the U.S., right? And so I define those units which are not available beforehand. So if I want to define feet per second, you just type quote FPS, so turn into units, colon, and then quote FT divided by quote second. And that's the FPS, that's what I define over here. And the gallons per minute, GPM, called over min. And so if I define a diameter of 5 inches, the next note has to do with the fact that when you define units in the English system or other units in the international system that are not standard, you always get back results in units of the international system. So 5 inches diameter will be defined as 0.127 meters. And a velocity. If I'm calculating the discharge velocity multiplied by the area of a pipe and use these values, my result comes out in cubic meters per second. But say I don't care about those values. I want my units in the English system. So what you want to do is you click on the right side of the result here, click on that placeholder and type quote GPM, gallons per minute, for example. Okay, if you want to in cubic feet per second, you can say Q equal and type and there and say quote FT cube space bar divided by quote S, and so on. And just be careful with that. Now, solving equations with units. When a simple expression is available to solve problems with units, the calculations are straightforward. So if you in a uniform accelerated motion, you know that the x position 0 is 10 meters, initial velocity 2 meters per second, acceleration 5 meters per second squared, and time 10 seconds. You can calculate your final velocity and you find a position in this way, and that's straightforward. The units are handling straightforward. But suppose that you're given x 500 meters and you want to say what time will it be reached or will be necessary to reach the position that are given. And so you take your equation here for the position and rewrite it in terms of t as the unknown, and that's a quadratic equation where I'm using alpha, beta, and kappa instead of ABC for the quadratic equation. And alpha is equal to 1/2 of A, beta is equal to v sub 0, and kappa is equal to x0 minus x. And then the quadratic equation will be this, and it gives you the result. In that case, there is a straightforward solution. But what if you don't want to use the quadratic equation and you want to solve for t using the function solve available in SMath Studio? You type the equation and you get no result because the units are not facilitating the solution. The problem is that when you try to solve something like this, you're solving for t, and we don't know what the units of t are, and neither does solve. And so one way to handle this thing is to take all the variables whose units are known, like acceleration, and divide by those units. And so acceleration a, you divide by m over s squared. Now that looks a little bit complicated, but it's not so. Velocity, divide by meters per second, x minus x0, divide by meters, and let it solve for t. So I'm going to type this so you can see it's not that complicated. Solve 1/2 space bar times a divided by quote m divided by quote s squared. spacebar, spacebar, spacebar times t squared plus v dot 0 divided by quad m divided by quad s. Spacebar, spacebar times t plus x0 minus x spacebar, spacebar divided by quad m for meters. This should be equal to 0. It's not necessary. It is assumed that that if you don't have anything there, it's equal to 0. But just to be on the safe side, put t, and I give you a result. Now, obviously, that result is in seconds. So to ensure that you get units appropriately to that, you have to do click in here and type times quad s, and that's your result. So divide all known values by its known units. Let it solve algebraically for the unknown, and then the solve function call multiplied by the units that you expect to your result. Now this is done down here. I'm going to eliminate that. And now you get your results. In summary, to solve an equation, retry the equation by dividing all variables whose values are known by the proper units, thus using the definitions, and multiply the call to the function solved by the units of the unknown being solved. An example from open channel flow, which is in civil engineering. If you have a step of size delta z, and you have a certain discharge q going to the channel, so that is depth y1 and velocity v1. It turns out that v1 squared over 2g is the head of the kinetic energy, and y1 is the head of the potential energy. And when you go over the step, typically when you have a high flow here, then you can drop your depth. And it turns out that this length here, y1 plus v1 squared over 2g, should be equal to y2 plus v2 squared over 2g plus delta z. And that's written in this way. Suppose you're given a certain unit discharge of the unit for discharge per unit width, a certain depth y1 and a certain delta z, and then g is just the standard value g sub e. Determine the depth of flow over y2. Well, we have this equation, right? And I'm going to show you here how to do that. And I type solve, and we're going to take this equation, put it in there, and we're solving for y dot 2, and of course you don't get any result. What's happening is that you need to divide the known values by its units. y1 is known, and so let's click to the right here and divide by quad m meters, right? Q, we're going to click to the right of Q and divide by its unit, which is meters squared per second. Quad m square spacebar divided by quad seconds. Within the parenthesis square, right? G, divide by quad meters per quad second square. Oh, you can put in parentheses if you want to make it more clear, so we put parentheses right there. y1, as I mentioned, it's known, so click to the right, divide by quad meters. Okay. In the right hand side, y2 is unknown, so we leave it like that, but q has this unit. So what we're going to do is just copy this, Control C, select the q, and do Control V. And so basically we divide it by that. Same thing with G. And if you want to put parentheses, go ahead. And then delta Z still needs to be divided by meters because it's a known quantity. I'm going to put some spaces in here. Divided by quad M. And that gives me some results. Those results should be in the units that I'm expecting, which is meters. And so I click in here and type times quad M, and that gives me the result. And this is the mathematical nature of the equation, where you get a negative depth, and that doesn't make sense physically. So you could, for example, type to the right here with quad 0 to 100, something like that. But it's missing the smaller value. Let me try something smaller here, 10. That's it. And so that gives me my positive results. And that's how you will handle this equation. It's a little bit complicated, I would say. But once you get it, then you get the power of function solve. Understanding the behavior of the solution. Suppose that you're not getting a solution for some reason. So what you want to do is check what's happening in the equation. And notice in this equation you have a left-hand side equal to the right-hand side. So you could, I'm sorry, including this term. You could create a function that it's the left-hand side or the right-hand side minus the left-hand side or vice versa. And we're going to call this function f of y dot 2 spacebar column. And so you could take the right-hand side of the equation, Control copy, Control C, paste it here, Control V, minus, and put a parenthesis there because you're going to copy the left-hand side. Sorry. That function needs to be driven to 0 when you find a solution. So that's basically the same thing as this. I'm going to delete this one. And so where is that solution? It needs to change sign for a root. And so if you took f of 2, and I'm using the fact that I know that the solution is at 1.72. So if we take f of 2, I get a positive value. If I take f of 1, which is on the other side of the solution, between 1 and 2, it gives me a negative value. So I know the solution must be between 1 and 2. There is a famous method called the bisection method where you take the result to 2, 1, 1, and then go to 1/2, and call it y sub n, for new, and then you get negative value. And then, so it changed sign at 1.5, but it remains positive at 2. So take that 1.5 and that 2, and that gives you 1.75, and it's getting closer to 0. And if you put you plot the function, remember there's a negative root that we ignore. I'm going to do this. I'm going to click here and drag it to the left, ignore the negative. And I do have a solution here and a solution there. And so that will give you what my solution is. And then when you narrow down the interval, for example, the first result here between 0 and 1, okay, you could change this to 0 and this to 1, and that gives me at 0.482. And then there's a result here between 1.5 and 2. So sometimes it's useful to create this function, which is the right-hand side and the left-hand side, to see how the function is behaving. And actually, I got those two results. So one value between 0 and 1, and the other value between 1.5 and 2. Exercise for an open channel. The equation that we use is this one, and if you're solving for y, you have to, as you can see there, redefine all that kind of stuff. I'll let you pause here and read and see if you can try to find that. This is a problem of open channel flow in civil engineering. You may not be interested in that, but if you are, I invite you to follow these instructions. And with that, we finish our video on the use of units in